Hi guys, so welcome back to another lecture of this Basics of Mechanics lecture series. Now in the last lecture we saw about the forces acting on a body, and we also saw how to mathematically represent the force and how to simplify the forces acting on a body to calculate the overall net force acting on a particular object or a body. Now in this lecture we're going to see about how to resolve forces. Now I have here an example. This looks familiar to us. There's some object which is being now subjected to force of 1 Newton from left to right, and the self weight of the object would be acting downwards. Now for this simple case we can able to calculate the overall net force acting on the horizontal direction and vertical direction using these formulas. Now the overall net force acting on the horizontal direction would be the sum of all the horizontal forces acting on the body, and the overall net force acting in the vertical direction would be the sum of all the forces acting in the vertical direction. Now what if there is a force which acts on a body in this manner? Now this is a bit inclined force. Let us call this as F newtons. Now this force is a bit inclined. It has certain angle, right? It has certain angle theta. Now where do we include this force F in our calculation of overall net force? Should that be included in overall horizontal net force, or should that be included in the calculation of overall vertical net force? Now in order to clarify this, we have to understand how this inclined force can be mathematically represented as horizontal and vertical forces, and this is what we're going to see in the next section. Alright, now let's see how to resolve the inclined force into their horizontal and vertical components. Now let us assume that there is this particle, this black dot, and there's an inclined force of 1 Newton has been acting on this particle. Now just to represent this a little bit easier, let us draw some horizontal and vertical axis with this particle as its origin. Okay, now that we have drawn the axis, let us assume that the force F is inclined at an angle of, say, 60 degrees from the horizontal axis. Now to calculate the horizontal and vertical component of this force F, we are going to consider a virtual triangle like this. Now let me draw that separately. Here's this force which has been acting on this body. Let us call this body as O. And let us close this triangle. And let us close this triangle. So just for the naming convention, let this be A and this be B, and this is the force F. Angle of inclination is, as we see, is 60 degrees. Alright, so now we're gonna use some trigonometry here and try to find out the basic trigonometric ratios. So let's start. Let's try to calculate the sine of 60. So sine of 60 degrees would be equal to the opposite side of a right angle triangle, that is AB, to its hypotenuse, which is the F force vector. So from this, AB would be equal to F times sine of 60. And now let's calculate the cos 60. It would be OB to F vector, and from this we can calculate OB is equal to F times cos of 60. Okay, now we have the two sides of the virtual triangle. AB is equal to F times sine of 60 and OB is equal to F times cos of 60. Now that we have found the horizontal and the vertical side of our virtual triangle AB and OB, let us try to understand what this implies when we are trying to resolve a force F into its horizontal and vertical component. Now you see this AB, that is this side of the triangle. Now we have calculated it as F times is F vector times sine of 60. So a vector times some scalar, you will get the vector as a result. So this AB is also a vector, so you can represent this side AB as a vector. Now where do you put your arrows? In which direction will the vector AB will act For that, F is going to help us. So F is acting in the downward direction. So obviously the AB won't be acting in the upward direction. It should be acting in the downward direction, right? So that is where we're going to put our arrows in. So AB is going to act downwards, and the magnitude of AB would be F times sine of 60, right? And similarly for OB, OB is also a product of F vector and cos of 60. So again, vector times scalar would again be the vector. So this side would also be the vector. And where are we going to put our arrows? In which direction? And for that, F is going to help us. F is acting from right to left. So this would be the direction of the side OB. Alright, and the magnitude of this would be F times cos of 60 degrees, right? So that's pretty much it. We have now resolved the force F into its horizontal and vertical components. So can we represent this entire system by representing this inclined force just as a combination of horizontal and vertical forces? So to do that, let me make some space in our page. Now that should be enough. Alright, so let us draw a particle O. And let us draw our resolved forces, that is AB, which is acting in downward direction like this. So this should be F vector times sine of 60 degrees, and OB, which is acting in the horizontal direction from right to left, which I will draw like this. So this is F of cos 60 degrees. So if you calculate this, F of sine 60 would be, sine 60 degrees is root of 3 by 2, and F vector has 1 Newton as its magnitude, so 1 times root of 3 by 2 would be equal to root of 3 by 2 newtons. So we can just replace F sine 60 with root of 3 by 2 newtons. Cos of 60 degrees would be 1 by 2, and we can replace this F of cos 60 as 1 by 2 newtons. So that is how we can resolve this inclined force of 1 newton, which is acting at an angle of 60 degrees, into two corresponding horizontal and vertical forces of root 3 by 2 newtons and 1 by 2 newtons, which will make our overall net force calculation much easier. Okay, now let's work this out for this given example. Now, in this diagram, we have two forces, 20 newtons and 50 newton. 20 newton is a pull which is acting diagonally from a point at an angle of 60 degree. Let's call this point as O. And 50 newton is a force which is acting at a 45 degree angle. So you can imagine that this point O is being pulled with 20 newton and 60 degree angle, and at the same time it's being pushed at 50 newton at 45 degrees angle. Now let's try to resolve these two forces and try to find out what are the horizontal and vertical components that is equivalent to these two inclined force. First, let me consider the force F1, which is 50 newton, and let me draw a virtual triangle over this at an angle of 45 degrees. So this point we know as O, and let this be A and B. So sine of 45 degrees would be AB divided by AO. So AO is equal to F1 of 15 newton. So let us substitute this in the formula here. So sine of 45 degrees would be AB divided by F1 newton. So AB would be F1 times sine of 45 degrees, which would be 15 newtons, times sine of 45 is 1 by root 2. So simplifying, you would get 7.5 times root 2 newtons. that will be our AB. Right? Okay, now we have got this AB vector, which is the vertical component of this inclined force of 50 newtons. And you might have rightly guessed that this AB vector would be acting in the downward direction. Yeah, let's mark that here as well. And let's move on with the calculation of OB vector, which is the horizontal component of this inclined force. So to do that, we would need to calculate cos of 45 degrees, which would be OB divided by AO. Now we need OB, so OB is equal to AO times cos of 45 degrees. AO is our F1 vector, so F1 times cos 45 degrees, which would be again equal to 15 Newton times cos 45 is again 1 by root 2. So we will again get 7.5 times root 2 newtons. So this would be our OB vector. Let's mark that as well. So the OB is the horizontal component of this inclined force, and this will be acting from right to left, and this has a magnitude of 7.5 times root 2 newtons. Alright, this is as far as the first inclined force is concerned. That is for force F1 equal to 15 Newton. Now we have to do the same procedure for the another force, which is of 20 newtons. So let's do that as well. Good, now let us consider the second force, which is of 20 newtons, and let's draw a virtual right angle triangle with that. So this has 60 degrees, and we call this as O, and let this be A and B as usual. Now let's start with our trigonometric ratios. So again, sine of 60 degrees would be AB divided by AO, which in this case AB would lead to F2 times sine of 60, and F2 is 20 newtons. Sine of 60 is root 3 by 2. So AB vector in this case would lead us to 10 Newton, or rather 10 times root 3 newtons. Right? Right, now let's draw this AB vector in our virtual triangle. AB is the vertical component of this inclined force, and since the inclined force is acting towards upwards, the AB vector is also will be directed in the upward direction. Let's move on and calculate the other component, the horizontal component here, OB. So for that we need to calculate the cos of 60. So cos of angle 60 would be OB divided by AO, and OB will lead to F2 times cos of 60 degrees. So since AO is equal to F2, F2 is in this case 20 Newton times cos of 60 is 1 by 2. So we would get OB vector as 10 newtons. So again, let's draw this OB vector in our virtual triangle. So this is the horizontal force or horizontal component of the inclined force, and this will act in this direction. Since the inclined force is acting kind of northwest, the horizontal force will be acting in the west direction. Okay, so now that we have calculated the horizontal and vertical component of both these forces, I have just summarized that in a new slide here. So let's draw these resolve components of horizontal and vertical forces of these two forces F1 and F2 into a separate force system which would be equivalent to the force system which we had previously worked with the inclined forces. Now, to differentiate between the horizontal and vertical components, I would use red color for F1 and yellow for F2. Let's first draw the horizontal and vertical components of the force F1. So the vertical component of F1 is AB, which is acting downwards, and it has magnitude of 7.5 times root 2 newtons. So let's draw that first in the downward direction. Yeah, and now let us draw the horizontal component of the force F1, OB, which is acting from right to left. With magnitude of 7.5 newtons. So let me write the magnitude of these as well, 7.5 root 2 newton, and this again is 7.5 root 2 newtons. Let's now come to the second force of 20 newton. The horizontal component AB is acting in upward direction, so let's draw it this way so that it's acting in the upward direction. It has a magnitude of 10 times root 3 newton, and the horizontal component of this F2 vector, or the F2 force of 20 newton, is OB, which is acting from right to left again. It has a magnitude of 10 newtons. Alright, so this is the way to resolve the inclined forces. Now you have, instead of two inclined forces, you have two horizontal forces and two vertical forces. You can simplify these kind of forces which are inclined into these simple ways, which will make your calculations much more easier. Alright, so that is it for today, and in the next video we will get a little deep into the theory, and we will see about the different types of forces, and I will introduce you also to the concept of resultant force. So that's it from my side for today, and if you find this video useful, please consider giving a thumbs up, and I will meet you again in the next video. Bye bye.